Okay, on to 7.6. The rest of this chapter is all going to be in factoring and solving. And remember, we can't lose sight, no matter what type of factoring we do, of what our goal is when we're factoring. We factor so we can solve. So we can solve these quadratics, these x to the squared. We're finding the roots. We're finding where these parabolas cross the x-axis, where the y is 0. What they're going to look like today, though, is a little different than what they looked like before. (7.5) and what we've done for the past couple of lessons and days and worked on, we were factoring quadratics that look like this. And the coefficient in front of the x squared was always 1. What's different today is now there is going to be some integer, could be an integer, could be a fraction as well, but for the most part we're going to have some number in front of here. Could be positive, could be negative, could be a fraction, more than likely not, but it's going to be something other than 1. So you can see, hopefully in your head you're thinking how this is going to change. The best way to do these, just like we did with 7.5, is to come up with this system and how we're going to solve it. So this is to factor. First thing you're always going to want to do with this one, look at it. We're always looking for a greatest common monomial to take out. I'm recognizing that there is a value here. There's a number in front of my x squared. So it's certainly possible that it could factor, and I'm going to try to factor it. What I want us to think about now is how these are set up, right? Remember, when I had this x squared here before, I immediately made my parentheses. These were all addition, and I could put an x and an x there because x times x was x squared. Well, now, this is a 4. And then I'm going to multiply it by some number, factors of 3. And when I would distribute that, I'd add those together to get that middle term. We need to consider the factors of 4 and the factors of 3 and come up with a possible combination that will give me the two binomials that were multiplied together to give me this trinomial. So the first thing I'm going to do is consider the factors of 4. I'm looking at what terms, what is going to go right here and right here in my binomials. And hopefully you can see this could either be a 1 and a 4 or a 4 and a 1, or these could both be 2, because I could do 1 times 4 to get 4, or I could do 4 times 1 to get 4, or 2 times 2 to get 4. And yes, there is an x there, so it would be x squared. So what I'm going to write over here is 1x and 4x kind of to start out. Those are the easiest factors of 4 that I'm going to consider, because I could have 1 and 4, or it could be a 2 and 2. Now what's nice about this one is there's only the two factors of 3. 3 is a prime number. My only factors are 3 and 1. I've got to look for the combination. When I multiply these together and add together, I get 13x. And I can see right now, if this 4x is multiplied by 3, that would give me 12x. And if I add it to 1x, that is going to give me 13x. Now I just got to figure out how to put this together in two binomials. I wrote these x's here because one of my first terms here in each monomial, one is going to be x and one is going to be 4x. So I'm going to write x here, and I will just write 4x right there. Now remember, to get that 13x, I wanted to multiply 4x by 3. So I got to think, where does that 3 go? Well, if I want to multiply it by 4x, it needs to go right here in the last place of my first binomial because I want to take that positive 3 times that 4x. I know these are all going to be addition because this is addition here. If I put the 3 here and the 1 here, and this sometimes can take a couple of these problems to figure out where they're going to go. That's why we paid so much attention in 7.4 of where do these numbers come from in this trinomial when I have the two binomials multiplied together. You can do a quick little FOIL to check this. 4x squared, that would be an x. 12x gives me 13x, and 1 times 3 is 3. And I've got the combination where it goes. Starting out nice and easy. 3x squared minus 7x plus 2. Definitely follows ax squared plus bx plus c because this in front of my x squared is not a 1, it's a 3. The nice thing about this one is 3 and 2 are both primes. The only factors of 3 are 1 and 3. The only factors of 2 are 1 and 2. Up here, I never even got to trying 2 and 2 because 1 and 4 worked. Where these get tricky is, let's say this was an 8 and this was, I don't know, 36. Something with multiple factors. Then I really got to start doing some guessing and checking, adding stuff up in my head, a lot of mental math to get it. This one's going to come out pretty straightforward. I'm looking at my signs here. My c is positive, this is negative. I know both signs of my binomial are going to be negative on this one, more than likely. I'm going to start out with my factors for that 3x squared. It could only be a 1x and a 3x, so I can go ahead and put these in because it doesn't really matter. It is going to be x minus something and 3x minus something because that's the only way to get 3x squared. The only factors of 2 are 2 and 1. Now I've got to put these together such that the sum is that negative 7. Well, hopefully you're realizing that those are both negative. That would give me a negative 6, and if I add that to a negative 1, that's going to give me that negative 7. This 3x has to be paired with this negative 2. Meaning 3x has to be multiplied by negative 2, which means my 2 would go there and my 1 would go there. Do a quick little check. X times 3x, 3x squared, minus x minus 6x. The sum is negative 7x, and I have a negative 2 times a negative 1, which is a positive 2. (4x squared minus 7x plus 3). Go ahead and pause the video a second. See if you can factor this. Okay, factors of 4x squared. Could be a 1x and a 4x. Could be a 2x and a 2x. I'm going to start with 1 and 4x. Only factors of 3 again are 1 and 3. Positive c value, negative. Signs of my binomial are more than likely going to be negative. When I add those together, they have to be because this is the product. The only way to get a positive product is if both terms are positive or both are negative. I'm going to try this 1x and this 4x. I'm looking for a sum of negative 7. Hopefully by when I write these factors, you can see that would give me 4. 1x times 3 would give me 3. 4 plus 3 is 7. This 4x needs to be paired with that 1. This 1x needs to be paired with that 3. My first two terms are going to be x or 1x and 4x again, just like in that first problem. Except now, this 4 needs to be paired with the 1, so it'll be subtract 1 and then subtract 3. So very similar to this one up here, but it's switched around a little bit with the subtraction and what I pair. Quick FOIL out. X times 4x, 4x squared, minus 3x minus 4. The sum is -7. -1 times -3 gives me a +3, and I got it. (2x squared plus 7x plus 6). The only factors of 2 are 2 and 1. But I have 1 and 6 and 2 and 3 for factors of 6. These are all addition, what's going to make it nice. I'm not having to really worry too much about my signs. What I do know right away is that this has to be a 2x and that has to be an x, and these are going to be addition. I know that just by looking at that. I'm going to write down my factors of 2x squared. That's going to be a 1x and a 2x. Factors of 6, 1 and 6. And then I also have my 2 and my 3. I'm going to try the 1 and 6 first. Now, 2x times 1 is 2x plus 6x. That sum would give me 8x. That's not the combination that I want. What could I also do? 2x times 6. Well, I can see right now 2x times 6 is 12x. I need that to be 7x. That's already way too big. I certainly can't use 1 and 6. What I can try, though, is my 2 and my 3, because that's my other factors of 6. Now, as soon as I write this down, it is popping into my head. 4 and 3 gives me 7. 2x times 2 is 4x. 1x times 3, 3x. That sum is 7x. My 2x has to be paired with my 2, meaning this 2x has to be multiplied by that 2 right there. When I say getting paired, I'm talking about what it gets multiplied by. If you happen to put the 2 here first and the 3 here to start, when you FOIL it back out and do a little mental check, it ain't gonna work. 2x has to be paired with 2. This x goes with that 3. I'll do a quick little FOIL. X times 2x is 2x squared. 2x times 2 is the 4x. 3 times x is the 3x. When I add 3 and 4 together, I get 7. So hopefully you're picking up on seeing, as these numbers get multiple factors, my A and my C value, that's when it really amps up as far as the possible combinations. And yes, we are going to get the ones just like what we did before, where my C value is negative, which means I'm really going to have to think about how I pair these together. Here's a 2x squared minus 5x minus 7. This starts out nice, and order is going to matter on this one. So the only thing I am going to write right now is my parentheses. And I know that one is positive and one is negative because this C value is negative, but I don't know how it's going to be paired. What I like about this one, though, is 2 is a prime number and 7 is a prime number. So the only factors of 2 are 2 and 1. The only factors of 7 are 1 and 7. This has to be some sort of combination of 2x and 1x and 7 and 1. But now I don't need the sum to be 5, I need the difference to be 5. Because one is going to be positive, one is going to be negative. So now I got to think a little bit, and I got to worry about my signs. If I take 2 times 7, that's already going to be 14. And whether I subtract 1 or not, that's too big. 2x times 7 is not going to work. It's way too big. I'm going to try pairing this right here. 2 times x is 2x. 1x times 7 is 7x. The difference between 2x and 7x is that 5x. But it needs to be negative, which means I need my bigger term to be negative, which means that has to be a negative 7, and that has to be a positive 1. Negative 7x plus 2x gives me that negative 5x. So now I got to think how I put this together. This 2x needs to be multiplied by a positive 1. So if I write 2x there, this has to be a plus 1 right there. My next term would be x, which has to be multiplied by the negative 7. Two x minus 7 times x plus 1. Do a quick little FOIL. 2x times x, 2x squared. Positive 2x minus 7x minus 5x. Negative 7 times positive 1 is negative 7. As you go through, you will definitely put these in the wrong spots. But this is guessing and checking. There's no other way to do it. We got to guess it and check, and if you put them in the wrong spot, that's fine. You're not going to go wrong if you FOIL it back out and think it through on where they came from. Three x squared minus 7x minus 6. I'm going to have you pause the video and give this a whirl. Okay. Hopefully we are going to be on the same page. What I know about this, the only thing I can do right now is make my parentheses of my binomial. I know that one is going to be addition, one is going to be subtraction, because that's a negative c value, but what combination and what goes where, I do not know, and I've got to think that through over here. What I do know, though, is that 3x squared, the only thing that's going to make that is x and 3x. Factors of 6 are 1 and 6, and I've got 2 and 3 as well. I'll start with 1 and 6. Now I'm looking for that difference of 7, and I can see right now 3 times 6 is 18. That's going to be way too big with a difference of 1. But if I pair it here, 3x and 6x, that difference is 3x. Doesn't matter what it is. I'm looking for that difference. Then I'll worry about the signs. Hopefully you see that. This is 6x. This is 3x. The difference is 3x. That's certainly not a 7x. 1 and 6 are not going to work. I know it's going to be 1x and 3x, and now I'm going to try 2 and 3. And as you can see, as the factors of these increase, the number of factors, the number of possible combinations increases as well. And we just got to put our thinking caps on, man, and we got to sort through it. We got to be persistent and grind them out. I'm looking for a difference of 7, and I can see right now that that is 9x, and that is 2x, and that difference between 9x and 2x is 7x. That's the combination I want. Now I got to think about my signs. Well, that's a negative 7, which means I want my bigger number here to be negative. I want that 9 to be negative because it would be a negative 9x plus 2x would give me the negative 7. That has to be my negative 3. This has to be a positive 2. Now I got to take care in how I pair this together. X has to be paired with the 2, meaning if I put x here, it has to be multiplied by a positive 2. That means my 3x would go here, and my subtract 3 would go there. FOIL it out. X times 3x, 3x squared, plus 2x minus 9x minus 7x, negative 3 times positive 2, negative 6. And I got it. You will see ones like this, and we ran into these on our multiplying polynomials when I got these negative answers. Whether it is an x squared plus bx plus c or ax squared plus bx plus c, the two forms that we've looked at, when we have this negative coefficient in front of my squared term, we want to get rid of that negative. We want to factor it out. Because by factoring it out, it will make it easy to factor in the long run because this coefficient is not going to be negative. Because if you think about it, if this term is negative, one of my first terms has to be positive, one of my first terms has to be negative, and that's where some mistakes are made. The first thing we do is factor out that negative or a -1, which means I'm just going to change the signs. That would be 4x squared plus 8x subtract 5. Get rid of this negative first by factoring out the negative. And remember, that's really a 1 there. I'm not going to write it. You've got to be able to distribute back through and get with what you started. Negative 4x squared, negative 8x, negative times a negative, positive 5. I got it out. This is what I'm going to factor with. This negative really doesn't mean anything here. It does in terms of the problem, but this is what I want, positive values, because it makes it easier to factor. This negative, or whatever we factor out, has to stay. I just bring it down, and I know, or at least I think, because we are doing factoring like this, this is what I'm going to try to factor. This term is negative, which means one is positive, one is negative. I got to consider factors of 4 and factors of 5. The nice thing about 5 is it's prime, only have factors of 1 and 5. I'm going to start with 1x and 4x, and I will start with 1 and 5. Now remember, I'm looking for a difference of 8 because that's negative. I can see right now if I take 4 times 5, that's 20. That's way too big because I'd subtract 1 away, or even if I added it, the difference between 20 and 1 ain't 8. If I do 4 and 5 though, 4 and 5, that difference is only 1. 4 and 5 don't work. Or 1 and 5 with the 1x and the 4x doesn't work. I got to look at other factors of 4, which are 2x and 2x. Now this is nice because it's not going to matter where it goes because they're both the same. But I got to think about my signs. Hopefully this is going to work. 10 and 2. 10 minus 2 is 8. Think about your signs. That's a positive 8, which means my bigger number has to be positive, which means that has to be a positive 5 and that has to be a -1. 10x minus 2 is 8x. Again, it doesn't matter. I can start with both of those because they're both 2x. Has to be paired with a -1 and a positive 5. And again, it wouldn't matter where I put those, but it would matter which sign. It has to be a positive 5 and a -1. 2x times 2x, 4x squared, negative 2x plus 10x, positive 8x, 5 times -1, -5. I got it. This is my answer. Last example, you're going to be asked to solve some of these, which means I'm going to use my zero product property, which means I will set it equal to 0, whether I have to rearrange it, put it in standard form, like on the ones we did yesterday when we were solving, or it could be given to you already set equal to 0, which is what I will do on this one. Negative 2y squared minus 5y minus 3 is equal to 0. Now just beware, I could have started this out with the 2y squared over here and the 3 over here, or the 5y, doesn't matter. What matters is when I'm asked to solve, we want to set it equal to 0. This one I just rearranged in standard form and already set equal to 0. But you may get them where you're going to have to rearrange them in standard form and set it equal to 0 yourself, especially in the real life problems. Has a coefficient in front of my y squared, and more importantly, it's got a negative. I want to factor out that negative to start to make it easier to factor. That would leave me with 2y squared plus 5y plus 3 is equal to 0. Negative 2y squared, negative 5y, negative 1 times 3 is negative 3. I feel confident in that. I need to carry my negative down. What I do know right now, I can make those parentheses. I know these are both addition, and I know that this is going to be 2y and this is going to be y, because that's my only factors of 2. So I could have 1y and I could have 2y, and my only factors of 3 are 1 and 3, and I want that sum to be 5. And I can see it right now. 3 plus 2. If I go 3 times 2y times 3, that gives me a 6y. That would give me a 7y. I don't want that. I want this. 3 plus 2. 1y times 3 is 3y. 2y times 1, 2y. 2 plus 3, 5. The 2y has to be paired with the 1, which means it goes there. Y has to be multiplied by 3. FOIL it out. 2y squared. 2y, 3y is 5y. Positive 3 times positive 1, positive 3, and I got it. Now, I got to solve. Remember, zero product property. Take this factor. 2y plus 3 has got to equal 0, which means I would subtract 3 and divide by 2. 2y is equal to negative 3. Divide by 2. That means y is equal to negative 3/2. Or it could be negative 1, because y plus 1 is equal to 0. I would subtract 1. Y is equal to negative 1. I have y is equal to negative 3/2. Or I could have y is equal to negative 1. And we're able to solve it. These take practice. We're going to start out relatively slow, and then it'll pick up really quick.